A couple administrative items before we begin the lecture proper. First of all, just a repeat, which is to say that problem set 4 will be due not today, but on Tuesday. So please bring that in, along with, if you chose to do it, the extra credit problem held over from problem set 3. So that's all due Tuesday. I'm going to distribute a long problem set 5 today. It's long, not because I'm trying to make you unhappy, but because it's intended to double as a review for the midterm. So there's a variety of problems here. Let me go ahead and pass this out. So so I said this is a review problem set. The best way to think about the midterm is probably to think of it as being, the best way to study for the midterm is probably to try to solve problems from the problem sets. So that's why I've given you a bunch of problems here. The midterm itself will resemble the problem sets in form and sort of the style of the question. Obviously, I'm going to try to make it a little bit shorter than the problem sets. I don't want you guys to be under a huge amount of time pressure. But the same person who's writing the questions for the problem sets is writing the questions for the midterms, and so you should expect the style of the questions to be similar. Yes?
I just have a trivial question. The 17th, am I kind of starting Monday?
That it's very possible we have a day calculated. So I have a due date for this 13th plus 18th. Thank you very much. Yes, this should be October. This should be due October 18th. Thank you. Rather than 17th, which is what it says at the bottom of the page if you haven't gotten your problems yet. Let's see, where was I? So you should work through the review problems. Some, maybe all, of the problems on the midterm will actually be just taken from the review problem set. So take it very seriously. I have repeatedly had the experience, but one time in particular a few years ago, where I handed out the review problem set and I said, okay, the midterm is going to be based on the questions on the review problem set. In fact, I might just repeat them exactly. And in fact, I wound up doing that. I just took a selection of problems from the review problem set. And afterwards, a student came up to me and said, "Gee, Professor Legan, you sure fooled us." So I think anyway, yeah. I thought it was fine. So some of the problems on the midterm will definitely be are in front of you now. So work your way through those problems carefully. What else do I want to say about the midterm? Oh, the midterm will be the format of the midterm. It'll be 80 minutes. We'll start at 10 after and go to 12:30. It'll be open book, open notes, closed mouth. So the focus here shouldn't be on a lot of memorization. You're welcome to use your notes to work on the problems on the midterm. Let's see, what else should I say about this? Are there questions? There usually are. The date of the midterm is a week from today, October 13th. It's before. Oh, I see. So Hillary asked the question, which is, so the midterm is due, but it will be before the problem set is due. That's correct. So we'll take the exam on Thursday. This will be due the following Tuesday. Because I'm taking some of the exam problems directly from the midterm. Because I'm taking some of the midterm questions directly from the problem set. If I do that, we're not going to grade the problems on the problem set. We'll just grade them on the midterm, so that you won't get sort of double counted. We may also choose to not grade all the problems on the midterm review just because it's so long. So we may have to grade a random subset. You're welcome to ask about any of those problems, though, either of me or in the discussion sections or office hours or what have you. Okay. Other questions? Yes. Oh yeah, sure. You can review the problem sets. Yeah. Now, whatever notes you have. I mean, so so the resources you'll have available to you during the midterm should be pretty close to what you have when you're working the problem sets, except that you can't rely on your fellow students. So open book, open note, closed mouth. Communicating over cell phones and things like that or email is certainly discouraged. But yeah, if you want to bring your textbooks or your notes, problem set, that's all fine. You should be careful in doing that. One mistake some people sometimes make is to think, oh, I got this book. It has all the answers in it. It's just, it's a textbook of microeconomics. And I mean, none of you are this naive, but the fact that the knowledge is sort of encoded in the book somehow doesn't necessarily make it so you can quickly transpose that knowledge to your exam. So don't rely on bringing a large stack of books and think that just because the knowledge necessary to complete the exam successfully is somehow in those books, you're going to be able to get an A on the exam. Okay. You're free to use a calculator. Yes, it's probably a good idea. I will. I'm not going to. I don't know. I haven't written the midterm yet, but you're certainly free to use a calculator. Other questions? Okay. So let's go ahead and start the lecture. My plan for today is to talk about a couple topics that are sort of leftovers. We actually completed last Tuesday the bulk of what counts as demand theory. So we've gone through a complete description of the consumer's problem, of the primal problem of consumer maximizing utility subject to a budget constraint. We've got Marshallian demand functions. We worked out indirect utility functions. We turned our attention to the dual problem. We worked out Hicksian demands. We worked out expenditure functions. We've talked about the principle of compensating variation and how to calculate it. And that's pretty much what there is to consumer demand theory. I mean, there's other odd bits here and there and other interesting things you can do, but this is the intermediate theory of consumer demand you guys have now basically seen all of. So there's a couple little bits left over I'm going to touch on at the beginning of the lecture today. Then I want to try, we'll see how this goes. This is sort of an experiment. I'm going to try to sort of talk my way through a little application, which will use some of these tools. It's an application related to one of the problems on the problem set I just handed out, having to do with demand for lighting on the problem set. If you want to take a look at it, it's number 15 on page 2. So I'm going to sort of work my way through that application a little bit, and that'll be the lecture. I'm also going to, if there's time left over, what I'll do is I'll entertain questions that you guys have about the problems that I just handed out. I plan to spend all of next Tuesday doing a midterm review. That also will tend to focus on questions, or may focus on other stuff too, but I encourage you to focus, to bring questions you might have related to the problems that I just handed out, if you have a chance to review that over the weekend. Okay. Any other questions about either administrative stuff or how we're proceeding? Okay, let's go ahead and get started. So I promised a couple leftover bits. We talked last time about the Slutsky decomposition. And we talked about how we can use the Slutsky decomposition to think about the effects of a change in price on demand for a good. And the example I gave last time involved what's sometimes called the own price Slutsky equation. I wrote it this way. I said the change in demand, for a small change in price, for a good I with respect, so the partial derivatives for a good I with respect to P, the price of the same good, is sometimes called the own price Slutsky equation. We have this, that it's equal to the same kind of partial derivative with respect to the Hicksian demand, minus something involving the Engel curve, the slope of the Engel curve. Okay, so that's the own price Slutsky equation. And so this is the answer, if you will, about how we can decompose a change in price, the effective change in price and demand for the ith good, into a substitution effect, and an income effect. So, and I drew some pictures, and I waved my arms, and I tried to argue that it was useful to divide up the Slutsky, the change in price and its effect in demand into a substitution and income component. Okay, there's a generalization of this that I'm going to give you now. It's called sometimes called the cross-price Slutsky equation, and it looks very similar, except that this thing gives us the answer to what happens if there's a change in the price of good J, for example, and the effect of that price change on demand for good X. So notice the only difference between what's up here on the screen and what is right on the board is that the prices have the subscript J on them, and this expenditure share here at the end also has a J on it. So this is the cross-price Slutsky equation. And so if there's so to take an example, if there's an increase in food prices that will have an effect on demand for food, and we can decompose that change in demand for food using the own price Slutsky equation, it may also have an effect on demand for clothing. And so if we want to figure out what the effect of a change in food prices is on clothing demand, we would refer to the cross-price Slutsky version of this. Okay, so just a little intuition right now. Why might it be the case that an increase in the price of food could affect demand for clothing? Why would we expect it? Why is that an interesting question to even ask? Yes, Kevin.
Where you're spending on food, the less you're going to have to spend on clothing.
Okay, so Kevin gives an answer related to the budget set, and this is, and his answer is, well, gee, if food prices go up, you've got less money in your budget to spend on clothing. So that's quite direct. That's a story about the income effect, and would show up right here. If in fact if the good is, if xi is clothing and xj is food, then this tells us something about the angle curve for food, if we get a big increase, if the food share in the budget is large, this income effect might be large, and so have a considerable effect on clothing demand. Let's think about two other goods. So that's the case where a change in the price of food might operate on demand for clothing. It's presumably going to do so mostly through the budget constraint, and so through an income effect. What about, let's think of two other goods. How about the price of, let's see, how about the price of sweaters and gloves? If there's an increase in sweater prices, why might that affect the demand for gloves? Yes? Yeah, so this is a case where there might be, I'm not sure my example's very good actually, but it's not just that the increased expenditures on sweaters is going to affect your budget set, it will, but it might also sort of more directly affect your demand for gloves. If sweaters are too expensive to buy, then you're not going to go skiing, so you don't need gloves, for example. So that's a case where the cross-price effect on demand, if sweater prices go up, it's going to operate mostly via substitution effect. All right, so those are examples. I've written up here also, just in elasticity form, this exact same cross-price Slutsky thing. That's analogous, precisely analogous to the elasticity form, the Slutsky decomposition we put up on Tuesday. Okay. This, I will just note in passing that either of these two things, either way of expressing it, is useful for a number of the problems on problem set 5. This Slutsky decomposition is very handy for answering a bunch of interesting questions about demand. That includes, well, let's see, number 1 here, for example. Also number 3. Oh, number 5 for sure. I would say also number 7. All those things are things you can answer quite directly just by manipulating this cross-price Slutsky equation. Okay. All right, so that's one point I want to make. It's sort of left over from last time. Any questions about this guy before I go on to the next augment? Okay. Here's another thing that I think I've touched on, maybe said some of these things in passing, but I haven't written them down for you. So I wanted to sort of state some of the properties of the Hicksian demands that we've derived when we talked about the dual consumer problem. So here's a fact. The first fact is this: Hicksian demand curves are always downward sloping. And so here's a mathematical statement of that one, except also a typo. Sorry, that should be not PJ but PI there. I apologize. So the mathematical statement that's there is not true. What is true is that DHI dPi is less than or equal to 0. Okay. Any thoughts, just intuition? I'm not going to try to prove it during lecture today. But any sort of intuitions about why that must be so? Well, so Tom says it's because an increase in price will decrease the demand. That's one way of interpreting this, I would say. But unless we know for sure that an increase in price always does reduce demand, I don't think that doesn't amount to an intuition about why this might be true. Let's do it this way. So we've got x1, we've got x2. Here's an indifference curve. And let's see what we know about this indifference curve. The thing about let's remember that a Hicksian demand is always going to keep the utility we derive fixed. So any Hicksian, if there's a change in price, we're going to stay on this indifference curve. So let's think about what happens when prices increase. We'll think about an increase in price of good 1. So here's one slope of prices. Let's associate this with p. If we increase the price of good 1, what happens to the parent demand here, the Hicksian demand? Okay, so that's right. So if we increase the slope of this, we sort of have to go back on this indifference curve somehow. So any higher price for good 1 is going to be associated with a higher slope for this curve, and so let's call it p prime, and a lower price. Oh, this is h1. H1 of p u star, h1 of p prime u star. And so the statement we're making here is just that anytime we increase p1, we have to shift in this direction. It's mechanically we just get a steeper slope here. Why is it the case that can't? Could we draw an indifference curve so that a steeper slope here would correspond to a higher demand somehow? What would that thing? Let's forget about the axioms we satisfy for preferences for a moment. If we have x1 here and x2 here, I want to draw one curve like this and another curve like this. Is there any way I could have an indifference curve that was somehow tangent here, but then also tangent up here somehow? So graphically, it's hard to do. As long as you have non-satiation being satisfied, you're going to find it very difficult. It's impossible to do that, I think. Okay, so that's some kind of intuition for this. As long as the slope of the indifference curve is decreasing as we increase x1, and that's a consequence of non-satiation, we're going to get decreases in Hicksian demand in response to price increases, our own price increases. Okay, is that sort of hand-wavy story there? Yes. Let's see. Starting from where? as long as it's the case, okay, so we get increases in slope, when prices increase, when P1 increases, we get increases in the slope of this curve. And so the question is whether or not that always implies lower levels of x1. So let's suppose it did. Let me try this again. I'm going to try it. Let's suppose it did, that increased slopes sometimes meant larger quantities of x1. So we could get that if we had an indifference curve that did that, for example, perhaps. Then we'd start off with a slope like this. We increase the price of good 1. There we go. And then a point like this would be tangent to this point. So this would, if we could have an indifference curve like this, an increase in price can move us from a point like A to a point like B. So what rules out that behavior for the indifference curve? Non-satiation in this case. This is also supposed to be the same indifference curve. So this point B can't be on the same indifference curve as A because it involves strictly more of both good x1 and x2, provided non-satiation is satisfied. All right. Here's another thing I'm not going to prove, but here's a statement of it. I dragged you guys through definitions of homogeneity, homogeneous functions a couple weeks ago. Here's one place that's useful. It's true of Hicksian demands that they're always homogeneous to degree 0 in prices. And so let me remind you what that means. It means that if you take all the prices, in this case, so we're not going to multiply the u, it's just homogeneous to degree 0 in prices. If we multiply all the prices, though, by some positive constant b, having h sub I be homogeneous to degree 0 means that has no effect on the value of the function. Okay, so, to take a concrete example, if we double all the prices that a consumer faces, it has a 0 effect on consumer demand. Does we have an intuition for why that is, why that might be? Yes? That's right. Okay, so very good. So if we double all the prices, there's no change in relative prices. That's exactly right. And what the Hicksian demand function does is really tells us about consumers' desire to substitute between different goods. The reason for that is because it's the same story we started with here. Hicksian demands are always going to stay on the same indifference curve, and we're going to find a tangency where we have something like P1 over P2, where this ratio is tangent to the indifference curve. If we double both P1 and P2, though, this doesn't have any effect at all on the slope of this thing for sort of obvious reasons. Maybe it's worth writing another example of that. Remember, the last couple lectures we worked out Hicksian demands for the case where we have utilities that look like this. So if we have u of x1, x2 equal to alpha log x1 plus 1 minus alpha log x2, what are the corresponding Hicksian demands for this guy, for this example? Well, so there's a so this is the utility function. I want a Hicksian demand. Is that where you were going? Okay, we don't want to do that. I want to get the Hicksian demand first, then we'll plug in D. So let's just think about the Hicksian demand for good 1. That'll depend on P1, P2, and some level of utility U. It's equal to something like the constant A. That again, we're not so interested in. What else? Or e to the U in this case. I'm just naming this thing U. What else? Yeah, okay, so P1, in this case, P1 to the alpha. P2 to the 1 minus alpha. Oh, sorry, hold on. No, that's not how I write it. I'm writing the sorry, I need to write P2 over P1 to the 1 minus alpha here. Okay, I think that's it. I was trying to write the expenditure function. Okay, so that's the Hicksian demand for this case. So what happens if we multiply both prices by a positive constant? Yeah, these cancel out. The only place prices appear are right in here, and this is true for this thing, but it's true of Hicksian demands in general. We wind up with expressions involving ratios of prices. So anytime you multiply all the prices by a constant, it just cancels out. So this is you multiply by b here, you multiply by b here, it cancels out. The Hicksian demands are homogeneous to degree 0. Okay. Here's another fact. This is related to the cross-partial Slutsky we talked about a little bit ago. The fact is that cross-partials are equal. And so let me say that in words. It means that if the price of good I increases, then the effect of that price increase for good I on demand for good J will be exactly equal to the effect of an increase in the price of good J on the quantity demanded of good I. I think I said that correctly. So it's kind of funny. I mean, maybe I should, instead of saying I and J, I should use real commodities. You can use food and clothing again if you like. So if there's an increase in, let's let I be food and let's let J be clothing. So if there's an increase in the price of clothing, that'll have some effect on demand. That may have some effect on demand for food. That's exactly the same. The magnitude of that change, that change is exactly equal to the change that we'd see if we saw an increase in the demand for food. I'm sorry, an increase in the price of food on demand for clothing. So I put the word why here. So it's kind of a funny fact, I think. Any intuition about why that is? There's one of the great economists of the 20th century is Paul Samuelson, and for his PhD thesis, he wrote what was basically the first modern textbook in microeconomics and mathematized much of this stuff. And something Samuelson said was he was talking about, he was reflecting on how much of economics, even fairly mathematical economics, just sort of was a way of formalizing our intuition. So that's one sort of view of using mathematics and economics, is that we can figure this stuff out, and it's just convenient to write it down mathematically sometimes. So Samuelson took the position that this was the only fact he could think of, but it was an important one, where intuition would never lead you to the result. You had to get it from the math, and so he thought about it a long time and had no intuition. Neither do I really, but it's an important and sort of deep fact about consumer behavior. Okay, questions about those facts about Hicksian demands? Let me ask.